Hi, I'm glad you can join me. Right now in this video, we're going to be looking at the outcomes in Pre-Cal 30S. Specifically, this video is about R9, and that covers arithmetic sequences and series. In this specific video, I'm just going to look at arithmetic sequences. So get your notes and let's get moving. Hi, okay, so we've got our notes and we're ready to get started. Lesson 1.1, Arithmetic Sequences. A sequence is a list of numbers that can follow a pattern. So the example here, -3, -1, 1, 3, 5, 7. What's happening from this number to get to this number? Well, we add 2. What's happening to get from this number to this one? We add 2. And you can very easily see that to get to the next number, we always add 2. In a sequence, each number is called a term. So this is a term, this is a term, this is a term, this is a term, and is represented by a subscript which indicates the term number. The first term is T subscript 1. So you see right here how that 1 is written smaller than the T and it's kind of lowered a little bit. That's called a subscript. That's that right there. The second term is denoted by T with a little 2 subscript, and the nth term is T with the N as a subscript. An arithmetic sequence is a list of terms produced by adding or subtracting a constant amount to each previous term. If the terms of a sequence do not change by a common amount, then the sequence is not an arithmetic sequence. So it's really specific to each term going up by the same number each time. It can also go down by the same number each time. That's why right here I say subtracting as well. So if you have a look at this right here, in the sequence 3, 5, 7, 9, what is T1? So that's the first term. The first term we see right here is 3. And the second term, that's that guy right there, that's a 5. And the common amount added to each successive term, so that basically means how do we get from this term to this one, to this one, to this one? What's happening each time? So the common amount added is 2. Now, what are the values of the next 3 terms not shown? Well, you're just going to take the 9 and you're going to add 2 to it, and it's 11. Then you're going to add 2 to the 11 and you get 13. And then you add a 2 to that and you get 15. All right. Now, very quickly, you can look at these here, and it's asking which of the following sequences are arithmetic. So which of the following sequences listed here go up or down by the exact same number each time? So hit pause on the video, and I want you to try these questions, and when you have them done, press play again. Okay, so hopefully you actually did press pause and you did these questions. So I'm going to run through them really quickly. For this one here, well, we add 1 to get to each one, each next one. So that's, yes, arithmetic. This one here, you see we go, how do we get to the 4? We add 2. How do we get to the 8? We add 4. And how do we get to the 16? We add 8. So this is not an arithmetic sequence. This one here, we add 2, add 3, add 1, add 1. So we also see that that's not an arithmetic sequence. Here, how do we get from this number to this number? Well, we have to subtract a 4 each time to get to the next number. So this is an arithmetic sequence. This one, how do we get from 0.4 to 3.0? Well, if you can't see it right away and do it in your head, something that you could do is take the 3 and subtract it subtract the 0.4 from it. So we get 2.6. And if you take the 5.6 and you subtract 3, you get 2.6 again. 8.2 minus 5.6 gives you 2.6. So this is indeed an arithmetic sequence. And this one we can very quickly see. You don't even have to do any calculations. You can really just look at the sign. How does it get from positive 1 to negative 2 to positive 3 to negative 4? This is clearly not an arithmetic sequence. So there's no number that you can just add each time or subtract each time exactly the same. So this one's minus 3, and then the next one you have to add 5, and so on. So the common amount that's added to each term is called a common difference. Okay, which is represented by a lowercase d, and it can be found by this formula here. Now, what this formula basically means is, well, you know what? I'm going to kind of let you guys look at this question right here and, well, try to figure what this one is, what this answer. Okay, so we're going to look at what the common difference is. So D equals the difference of the term values. So basically, remember what we did over here? We went 3 minus 0.4. So I took two successive terms here. And the M and the N represent the term number. So here I took the second minus the first, and the denominator here would be 2 minus 1, so there'd be a 1 there. It's basically rate of change. So if you kind of think of rate of change from last year, this formula will make kind of more sense to you. This next question says, find the common difference and the missing terms. So you're given 3, which is the first term, that's T1, and T2, T3, T4 are missing, and then you're given T5. I want you to figure out what you think this is, and just by your intuition and playing around with some numbers, press pause, give yourself a couple of seconds, and give that one a try. Okay, so now that you're back and you've tried this question, you want to look at what the difference is between here and here. So there's a difference of 20 in between, right? And this one is halfway in between. So what's half of 20? Well, that's 10. So to get to here, we add the 3, and this is 13. And we could do the same thing to get this number and this number. If you're not so good at just kind of thinking through your numbers and you want to use your formula, let's use the formula. So we're going to take the last term that we have here, which is 23, the first term, which is the 3, and the term number of the first guy that we use. So this is the 5, and the term number of this guy here. So then that gives us 20 over 4, and it gives us a common difference of 5. So that means that we add 5 to the previous term to get to the next term. So 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. So we know we're good. All right. Next page. What if I gave you an arithmetic sequence 5, 8, 11, 14 and asked you for the 15th term? So how are you actually going to do this question? Well, there's two ways. There's the long and treacherous way, which is just adding, let's see, what's the common difference? So we have to figure out the common difference. Okay, so that's add 3, add 3, add 3, right? That's kind of obvious. So our common difference is 3, and we could just keep adding 3 until we get to the 15th term. So we've got 5, which is our first term, and then how many more times do we have to add 3 to get to the 15th term? Well, think about it. We already have this one. This is the first one. And then how many more terms do we have to write down to get to the 15th term? 14, right? That's one less than they're asking for. So you could do this, and this is absolute torture. 5, 8, 11, 14, 17, 20, 23. I'm already getting tired. Okay, you know what? Forget it. I bail because it's just too much work to do it that way. And so on and so on. And get to the answer. This is going to be the 15th term. You can continue that if you want. I'm not going to. I'm just way too lazy. Now here, what if they asked for the 57th term? Oh my goodness. Okay. So I know the first term is 5. Now, remember we talked about how many more terms do I have to add? How many more times do I have to add the 3? Well, in here, I had to add the 3 14 more times to get to the 15th term. And you can actually try that. What would I do here? So I would have to add the 3 how many more times? 56 more times, right? Okay, so now you can just kind of quickly use your calculator and just type that in and get that it is 173. So I've got 173. So the 57th term is 173. All right. The next part asks to determine the general term of the sequence, T sub n. We are going to use the formula. So this is basically just what we talked about, right? To find the term that we're looking for, take the first term, and how many more terms do we have to add on to minus 1 times the common difference. So here, Tn is the value of the term. T1 is the value of the first term. Here I should write nth term. The value of the first term. So right here we need the first term. And n is the term number. That's crucial. It is not the value of the term. And then d is the common difference. So I'm going to work through this question with you. And then what I want you to do after I'm done this question is hit pause, try the other ones, then we can continue. So T1 here is 6. The common difference is add 2 to get to the next. And I want the term number is 10. So to find T sub 10, I have my formula here. And I plug in the values. So what is n minus 1 going to be? That's just going to be 9. And times 2, that's the common difference. And we get that equals 24. So the 10th term is 24. Okay? I want you to hit pause, and I want you to try the next question. And I'm going to come back with the solutions. Okay, so now that you've hit pause and you've tried that, T1 is 9, D is 7, N is 18, and T18 is 9 plus 17 times 7, and that equals 128. So the 18th term equals 128. For this one here, we've got T1 equals minus 4, D equals minus 5, N equals 9, and I'm looking for T9. Minus 4 plus 8 minus 5, multiply those together. Remember order of operations, multiply these two guys before you add that guy on. And we end up with minus 44 because what's happening? We're going more into the negatives each time, right? So the 9th term is minus 44. Okay, and this question right here, D equals negative 12, T1 equals 23, N equals 6. So find T6, that is first term plus N minus 1, that's why this is 5, so 6 minus 1, minus 12, that's the common difference, and that gives us negative 37. So the sixth term is minus 37. All right, hopefully that went well. Now we're going to look at the number of terms in each of the following sequences. So here you're given a list. You're given a few terms successively, so we can figure out D from that, and it's pretty obvious that D is 5. We've got the first term here, which is 10, and Tn, this is what Tn is right here. That's the last term, the nth term. What we are asked to figure out is which term number it is, what n is for this here. So how many numbers are in this actual list? That's what we're looking for. So so fill in what we know, and then we have to solve for what we don't know. So we're going to use the same formula, and Tn, that's our 250, that goes right here. T1 is 10 plus n minus 1. Well, n is what we're looking for, right? So let's actually find our n. N minus 1, we have to write n down, and our common difference is 5. All right, so now it's simple solving for n. 250 equals 10 plus 5n minus 5, and we simplify that. We get 5 plus 5n. 245 equals 5n, and we get n equals 49. So for this question here, we have 49 terms. In this sequence. Okay? Now, hit pause, try this next question on your own, and I'll show you the solution. All right, so D equals 3. We add 3 to get to each one. Our first term is 1. Our last term is 121, and we're trying to figure out what n is. So set up the same type of equation. 121 equals 1 plus, and just make sure you distribute that 3 properly, okay? That's a pretty common error that happens, and it's very avoidable. Okay, so we get 123 equals 3n, and n is equal to 41. So this one has 41 terms. All right. Okay. Now, the last page here on this section asks you to figure out some information. It's a little more digging that we have to do. So we've got the 14th term of an arithmetic sequence is 78, and the 19th term is 193. Okay, so we have to figure out what our common difference is. So let's just write down what we have. So we've got T1, sorry, we don't know T1. T14 equals 78, and T19 is 193. Okay, so to find the common difference, we want to subtract the terms that we have together. So subtract go 193 minus 78, and then the term numbers, so where their location is in the list. So we get 115 over 5, and we figure out that the common difference is 23. So we add 23 to get to the next number. All right. Now, what is the first term? So now we can figure out what the first term is using one of these to help us out. So we can use the fact that we've got n equals 14 and the 14th term is 78. We know the common difference is 23. So if we use that equation that we saw earlier, which is Tn equals T1 and then n minus 1d, and fill in what we know. So we know that the 14th term is 17. Whoa, sorry. Don't know where that came from. The 14th term is 78, and T1 we are looking for, I forgot a plus sign there, that's important. And then we've got our 14, right? So what is 14 minus 1 going to be? And that's 23. So here we've got 78 equals T1 plus 13 times 23. And you can solve for that, and you get T1 equals minus 221. All right. So I guess that's where the 17 came from. So here we've got, what's the 17th term? So n equals 17, and d equals 23, and we know T1 equals minus 221, and this is a fairly standard, simple question. I'm just going to go in and write the numbers in right away. So minus 221 plus, and 17 minus 1 is 16, and 23, and I get that the 17th term is 147. Okay. All right. Try this one. Hit pause. I'm sure you can do it. All right. So you've tried this question, and this is what you came up with. And we get 446 for the 30th term. All right, what's the general term? Well, the general term is basically the general equation that you're going to use to find any term in the sequence. We pretty much found it up here, right? So it's basically saying, if I didn't know what the value of n was, if I didn't know which term I was looking for, how would I be able to figure that out? Well, T1 is always the same. All right, so you write that down. And n is what we don't know, but we do know that we have to add 23 to each successive term each time. And we can simplify this. So if you can simplify it, 23n minus 244. So this right here is your general term. Okay, now we're coming to the end of it. This last example asks you to find a formula for the nth term of an arithmetic sequence whose common difference is 5 and whose second term is 12. So right here, this is important. That means d equals 5. And right here, it's saying the second term, so that's T2 equals 12. So what are we missing? We need T1, right? Well, basically this is what it says. That's T1, I don't know it, and this is T2. That's my second term, and it's 12. And to get from here to here, I added 5. So how am I going to get back? How do I figure out what the first term is? Minus 5. Minus 5 from the 12, and we get 7. So that just gave us T1. So Tn is equal to T1, which is 7, plus n minus 5, n minus 1 times 5. And then we can simplify this. Make sure you distribute the 5 through. 7 plus 5n minus 5. And Tn is equal to 2 plus 5n. And this is going to give us the general formula to find any term in the sequence. So if I wanted to find the 18th term, I would say n equals 18, and then I would use that general term that I found up there, substitute the T18, substitute the 18 for the n, and it's as simple as that. So the 18th term is 92. Okay, so I hope you've enjoyed this video. I hope you were able to follow along. Remember to always use the pause replay button, and if you have any questions, make sure you ask us. Also, it's crucial that you do your homework, so I've got some recommended exercises right here. Because the only way to beef up your math skills is to practice. So have fun doing the exercises, folks, and we'll see you again soon.